It is my pleasure to be with you in organic chemistry lecture. We start from the beginning, so this will be useful for secondary school, also with science or anyone start to study organic chemistry. Organic chemistry means any compound contains carbon and hydrogen. So if the hydrogen only, it means it is only one bond. If it is oxygen, it means double bond. If nitrogen, it should contain 3 bonds or 5 bonds. If it is carbon, it means 4 bonds like that. So please remember, you must know by heart, if it is only one carbon in the chain, it should be, you should say methane, ethane, propane, butane, pentane, hexane, heptane, octane, right? Then we go to the functional groups. So what means a functional group? It means that the group contains oxygen or nitrogen or sulfur. So if it is carboxylic group, then it is acid. And the name will be like, for example, here ethane, it will be ethanoic acid, when it is 2 carbons. If it contains imide group, then it will be ethanamide, for example. If it is COO, remember here, not H but R, then it is completely different, ester, and it is O8. If it is RC double bond OH, remember the carbonyl here attached to hydrogen, then it is called aldehyde, al, like for example, it will be ethanal if it is 2 carbons. If the carbonyl attached with R, with any group, then it is carbonyl. So this is the difference between ketones and the aldehyde. Aldehyde is one active hydrogen. That's why it is more stronger than ketonic group, because it can be easily oxidized. While ketone, you add on. If it is OH, it means alcohol. If it is NH2, it means amine group. What about if it contains double bond, then it is ene. If triple bond, ene. If no double or not triple, it is ene, like here. So what is the difference between these groups and this group? When it is no oxygen or nitrogen or sulfur, it means that the compound here all are non-polar, because they doesn't contain any oxygen or sulfur, and this affects on the solubility. It affects also in the boiling point. What means boiling point? Boiling point means that if the compound is evaporated, it means it changes from liquid state to evaporated state. Like when you have water and you boil it, if you keep it boiling, the water will be decreased. What happens? It changes at 100 degrees, which is a boiling point, then it changes from liquid to vapor state. Right. What is the effect also of the functional group? The functional group affect dramatically in chemical reaction. That's why when you have the functional group, it means you have priority for nomenclature, which I will show you. So, for example, if you look to this one, 1, 2, 3, 4, I can hear you. It's called the butane, ANE. And if you calculate, it is C4H10. So if you apply the rule CnH2n, it means 4 multiplied by n, which 4 multiplied by 2, it means 8. But this is 10, so we must add here 2. So you don't need to memorize. You will like organic chemistry, you will love it when you understand it. Then you can practice. So first, you make the nomenclature N. What about if it contains double bond? Now I can hear you. Then you make the numbering with the list number. So the list number is 2. Then you write 2, because the double bond started from 2. Then you say 2. Butene, ENE. Then you calculate how many carbon? 4. How many hydrogen? 8. If you apply the rule, 4, and the 4 multiplied by 2, it means 8. So it should be CnH2n, right? When it is triple bond, same way of nomenclature, then it is 2-butene. If you calculate carbon for hydrogen is 6, so C4H6. If you multiply it by 4 by 2, it should be 8. But now it is 6, then it should be minus 2. So 4 multiplied by 2 is 8, 8 minus 2 is 6. So now you can conclude the rule of C2H2n by yourself. What about isomerism? What means isomerism? It means if you look to this compound, how many carbon? 4. If you look to this compound, 1, 2, 3, 4. So they are the same. But what happened here? One carbon carry 2 methyl groups. So these 2 methyl groups carried by only one carbon. Then we must say isobutane. Other way of nomenclature, 1, 2, 3. So it will be 2 methyl propane. So now you understand how to do the nomenclature. What about if you would like to put functional group? How you do the nomenclature? Very easy. So for example, if here substitution of hydrogen, it means it will be only 2. This means this is alkyl group, which you can say butyl. Now it is butyl because you remove hydrogen and you put, for example, OH, then it is butyl alcohol. Or you say butanol, like this one. So very easy. What about if you put carboxylic group, C double bond O, OH? You know carboxylic group is very strong, right? Because it contains two groups, C double bond O and OH. Then you call it how many carbon? 1, 2, 3, 4, 5. Because now you increase it with carbon. So it is 5 now. Then it is bentanoic acid, right? So if it is like this, then it is butanoic acid. Butanoic acid, right? Butanoic acid. What about if you put here hydroxy group, for example? So I remove hydrogen and I put here OH. How you do the nomenclature? Then you must start to do numbering, and the numbering should be least in the least substitution. But now you have two substitution, OH and the carboxylic. What will be the priority? You go to this rule. Here is the carboxylic group, and here is the OH group, which is more stronger carboxylic. This means that you start to do the nomenclature from this way, right? Not from this way, because carboxylic group has the priority. Then you start with this numbering. 1, 2, 3, 4. So this OH will be taken the number. And the same here, you do the same. If you have amine group, then you do nomenclature in the same way. I hope it's clear for the nomenclature before we go to the chemical reactions. Now we go to addition reaction. What means addition reaction? If the compound contain double bond or triple bond, this is the condition. So if, for example, it is contain double bond, let us take it in simple way. If the bond migrated to this place, it means it goes from one to another place. Like I gave, when I have this pen, I give it to you, this will be rich and this will be poor. Rich means negative charge, and the place it left, it is positive charge. Same here, this will be moved to this place, then it will be negative and this is positive. So when you add HBr to double bond, it has activation, then it becomes dipole. So this will be negative, it will take this positive. And this one is negative, it will go to the positive. So the first step is the hydrogen positive go to negative, like this way. Second step is the negative go to the positive. Of course, the double bond will be broken, right? So this is, we call it the mechanism of reaction. Like for example, bromine, it will be the same. Migration, then it form positive and negative, and it will be added like this. That's why if you add bromine, the bromine is orange in color. If you add it to compound with double bond, the orange color will be decoloration. So the color will be disappeared. It will change to colorless. Why colorless? Because it is added. The bromine will be consumed already. And the same with hydrolysis. Let us go to this scheme. If you take the ethylene, if you add hydrogen, for example, H and H, it will be the same. Now you know it. Breaking of the double bond, add one hydrogen here, like this. With this reaction, by the way, they use it in the manufacture of margarine, for example. If you add bromine, as I explained, breaking of the double bond, add brom here and brom here. So it is addition to both carbons carry the double bond. The same with hydrolysis, H and OH. And of course, if you write this, CH3, CH2, OH is ethanol. So this is a manufacture of ethanol. Of course, they do manufacture of ethanol from molasses and the other stuff too, because this way is more expensive. Is hydrobromination. What means hydrobromination? Hydrogen is hydrobromination. It is the addition reaction too. And by the way, elimination reaction is the opposite of addition reaction. So if you have this compound and you do elimination reaction, what means elimination? Elimination, it means removal of the two hydrogen. So if you remove this hydrogen, it means the carbons will be less in numbers than you add double bond. The same here. If you remove HBr minus HBr, it will be removed. H and Br will be removed, then you form the double bond. The same here, if you remove this bromine, it will form the double bond. Now you like chemistry, because addition means breaking of the double bond and add to both sides. The opposite way, if you remove from both sides, you form the double bond. On the other hand, if you take many molecules of this one, like N, and the ethylene added to itself, it forms a polymer, and this is what they use it for manufacture of plastic. Because you know, organic chemistry is our life. It is used for, you can see, for manufacture of alcohol, for plastics, for etc. Now we go another type of reaction which you understand, no memorize. If you take this one, NaOH, and here HCl, look what is the type of compound. When it contains hydroxyl group, it means it is base. When it contains hydrogen, it means it is acid, because acid is proton donor, right? So first you write positive, negative. Here positive and negative. So sodium will take the chloride to give sodium chloride. You notice that we start any compound by positive, by the way. So Na will take Cl, and then H will take OH to give water. If this base and the acid, you get neutral, which is the salt, right? Now you can practice with me. Sodium hydroxide, I can hear you. Sodium is positive, OH is negative. Hydrogen positive, nitrate is negative. Then sodium will take H, no, NO3. So it will give NaNO3, which is neutral. Then H will take OH, then plus HOH. So you see, and this very simple way to do the chemical reaction all the time like that. Then if you go to another type of compound, look to this, we explained before, carboxylic group, which is like ethanoic acid, 2 carbons. Remember to count the carbon when you do the nomenclature. Plus ethanol. Again, this OH will be removed with hydrogen. Why? Because this is condensation reaction. It means produce water, right? Then you write the rest. CH3, CO. Then how you continue? You continue CO, C2H5O? No. Because this is the active position. Very important. From the active positions, you make the connection. So CO will attach to this oxygen. That's why you find it, and this you call it ester. By nomenclature, you count all carbons. So this group first, this is ethyl group. So you start with this ethyl group, right? Then how many carbon here? 2 carbon. Then ethanoate, because the ester take the prefix OAte, right? As I usually say, play with molecule. You can put here any alkyl group. It doesn't matter. So if you put, for example, here this group, no problem. You can put also the carboxylic group this way. Why? Because when you put it this way, then you know that it contains 2 groups, carbonyl and OH. And that's why you will remember that you remove OH from the acid. You don't remove OH from the alcohol. Why? Because acid is more stronger, as I told you before. That's why OH removed from acid. Now you will not forget. And removed with hydrogen as water. Then where you connect? You connect the 2 molecules in the 2 active centers. So CH3, CH2, CH2, CO, O, C3, H7. How you do the nomenclature? You practice on it in the same way. Practice here on the ester. How you make the nomenclature? Start with this group first, which is propyl group. Then how many carbon here? 1, 2, 3, 4. 4 is butanoate, prefix OAte. So and how this reaction is useful in industry again? It has a good smell, so it's used in perfumes, right? It is also used in oil, lipids, fats. Accordingly, it is also used as a solvent. And by the way, this solvent is more stronger or more common, and it's called the condensation reaction. I hope after this lecture, please kindly try to practice. How you practice? You put compounds like this, and you start to do reactions by yourself. Also for nomenclature, put names like, for example, you put propyl butanoate, right? Propyl butanoate. Then you draw the structure. So make it in the opposite way. This will help you a lot. I hope you contribute this video so everybody could love organic chemistry, and we will continue in the next lecture with another type of reactions. Thank you very much for your kind attention. See you again.